Right, so we've got this 3D trigonometry problem here, angle of elevation, yep, cool, distances, so you can see the picture on this sheet here. Sorry, like, we look at this topic of 3D trigonometry in like a textbook or on a piece of paper, but that's not real 3D trigonometry. This is real 3D trigonometry. So here's the problem. We're trying to find the height of the tower. Now, unfortunately, we don't really have a long ruler, so we're going to have to use the power of 3D trigonometry. The information we can find easily are two things: angles of elevation and compass bearings. Another thing that will help is labeling certain points of our situation with letters, so we can easily reference them. This bird's eye view here shows clearly the different points, A and B, and where they are in reference to the tower. At the bottom of the tower, we have O, and at the top of the tower, we have T. And so the whole goal of this problem is to find the distance OT, which is the height of the tower. Using a clinometer, we can measure something we call the angle of elevation, which is the angle created by looking at the horizontal and going upwards to a certain point of interest. In this case, the top of the tower, which you can see as I look up towards it. And using this clinometer, we find that the angle of elevation is in fact 23 degrees. From another point B, which is a bearing of 120 degrees from the tower, the angle of elevation of T is 32 degrees. Now, we also know that the distance between A and B is 200 meters. And hopefully it's really clear here that when we're talking about our bearings, that we're always measuring them from north. You can see point A here is directly south of north. Point B, when I say on a bearing of 120 degrees, it's creating that angle here. And the question now is, we have all this information, how do we put it together and actually solve for what the height of this tower is? All right, back to the classroom. All right, so let's have actually look at the calculations of this problem, right? So part one says we're going to copy the diagram and put any given information. And we've actually got the diagram here already drawn, but what other extra information do we have? If you look at the question, right, we're told that AB is 200 meters. Now that's actually not given to us, so I'm going to mark that in. The other thing that we know is we know some angles of elevation, right? The angle of elevation from A to the tower is 23 degrees. And the angle of elevation from B to the tower is 32 degrees. And here's my first tip when we're looking at 3D trigonometry. Okay, you can see already when I've got this diagram here, it's a bit confusing with all these different lines going here and there. Like this 32 degrees is trying to reference that particular angle, but then I've got 120 degrees on that ground there. So my first tip was, when we're looking at 3D trigonometry, even though the question hasn't asked us to do this, my first tip is to really draw separate triangles which represent the situation, right? So what do I mean by that? Well, when I'm looking at drawing separate triangles, I can see, right, there's a triangle here with AT, right? We can draw that one there. Notice that that's a right angle. That's 23 degrees. I don't know what this height is. You might let OT equal to H, right? That's the height, so we've got H there. What else do we have? Well, we've got this triangle here, TOB. So let's mark in what these are. So we've got AOT, and we've got TOB, looks like this. And that's going to be 32 degrees. That's still going to be H. And you've got this triangle here. And the great thing about this triangle is you actually know some additional information. You know that that angle there is supplementary with that 120 degrees. So you know that's going to be 60 degrees. There's AOB. All right, and you know that because that angle there is 120 degrees, that this guy has to be 60 degrees. So let's put that in there. 60 degrees there, and that's 200 meters. I don't know what these lengths are, but that's going to come into play in the second one. So part two. Right, so I'm trying to find H here. And although we don't know what H is initially, the great thing about drawing my separate triangles is that once I've drawn them like this, now what I can do is I'm thinking about how can I relate them together. Okay, so another tip in 3D geometry. Right, think about how can you relate the different sides together.
Right, so we've got these perspectives. How are they going to be related? Right. First of all, you think about this. Okay, I know that, for example, AO can be found here, and it's also in this triangle. And OB can be found here, and it's also in this triangle. So those are the parts that link them together. The kind of bases of these triangles are the sides of this triangle here. Okay? So that's something I'm keeping in the back of my mind. And I know that actually, right, if I can try and bring H into this equation, that's something that I can then solve. So that's another common thing there, right? H is related to these two triangles here. How am I going to tie this all together? Well, what I'm thinking is, I've got the most information here actually. Right? And if I can find these sides somehow, then I can start to bring in cosine rule. Right? I'm thinking, okay, 3D trigonometry, sine rule and cosine rule, those are going to be things that I can bring into this question here. So let's try and do that. Let's express H in terms of these guys. So we've got, in this one, we've got opposite over adjacent. So that's my tan ratio when you're SOHCAHTOA. So from that triangle, I've got tan 23 degrees is equal to opposite over adjacent, or H over, I might just do it over there, just to make it really clear. Jeez. Got like 10 minutes. So we've got tan 23 degrees here equals to opposite over adjacent, or H on OA. And here we've got, and we can make, no, we want to make OA the subject, hey? So that we can actually bring it into this. So bring it to the other side. So OA times tan 23 degrees is equal to H. And so OA is equal to H on tan 23. So that's what OA is there. And then let's do the same for here, right? So same opposite over adjacent. I say that tan 32 degrees is equal to H on OB. And so making it the subject again, OB times tan 32 degrees is equal to H. And so OB is equal to H on tan 32 degrees, right? So you can see I've related these guys together, and OB can be found there. So now that I've got these things in terms of H, can you start to see what's going to happen? If I put in think about the values I need for my cosine rule, right? Cosine rule says that if I have this guy here, we can say c squared is equal to a squared plus b squared minus 2ab cos c. What are the a, b's, and c's? Well, remember, c has to be the included angle with the sides that you've got there. So I know that c is opposite that angle that I've got. So c squared is going to be 200 squared is equal to OA squared plus OB squared minus 2 times OA times OB times cos 60. All right, so we've got that line. So how is this going to help us? Well, we know now what OA and OB are. We can actually just substitute those in. There's my H on tan 23 and H on tan 32. Right? So H on tan 23 all squared plus H on tan 32 all squared minus 2 times H on tan 23 times H on tan 32 times cos 60. All right, so what do I do with all this now? This is actually going to be quite nice because we can realize a few things are going to simplify out. I've got H squared on tan squared 23 plus H squared on tan squared 32. And we've got these 2's here, but cos 60, another way to write cos 60 is just half. And these guys are going to cancel out, so I'll get H squared on tan 23 times tan 32. So now you can see, hang on, what's the whole goal of this? The whole goal is finding H, the height of my tower. So if I want to get H by itself, I can actually just factorize that whole thing. I want to have 200 squared is equal to H squared outside of all of this guy. 1 on tan 23, 1 on tan squared 23 plus 1 on tan squared 32 minus 1 on tan 23 times tan on 32. And if you do a bit of rearranging here, you'll get that H squared is equal to 40,000 on, so divide this by this whole side. This ends up being about 4.3 something. 4.340. And so what's the answer for that? Well, we take the square root of both sides. So h is equal to about 95.99, but we're going to the nearest meter, so therefore h is 96 meters to the nearest meter. So you can see, that's how we go through that whole process. Like, we start from this diagram, which has a lot of things going on here, then we break it up into these pieces, and we see how we can relate them to each other and bring it all together to get your final answer, h, 96 meters. Easy.
I hope that was some good insight into what is real 3D trigonometry, seeing it in the world around us and not just on the pages of a textbook. If you want to see more content like this, like and subscribe for more maths lessons, and see more here below as well.